Today we discuss about atomic spectra. We know that when sunlight is passed through a prism, it gives a band of 7 colors called spectrum. Different colors differ in wavelength and frequencies. However, when hydrogen gas is taken in a discharge tube and a high voltage is applied between the electrodes, light is emitted. This, when passes through the prism, gives a series of lines in the spectrum called as line spectrum. When suitable deflecting devices or analyzers for wide range of radiations are used in place of prism, a spectrum extending in the whole range from ultraviolet to infrared region is obtained. The spectra of elements are dependent upon the nature of radiations emitted. Each element will have its own characteristic spectrum which will be different from that of any other element. Since each line in the spectrum is having characteristic frequency, it will have definite energy, means E is equal to h nu. The line spectra shown by atoms of elements are known as atomic spectra. Consider an example of hydrogen atom. Since hydrogen atom contains only one electron, its spectrum is the simplest to analyze. The hydrogen spectrum is shown in figure. First, the atomic spectrum of hydrogen in this figure. Then it consists of a number of discrete lines in the visible and ultraviolet region. It is due to spectral transition of hydrogen atom. Each space between the two lines corresponds to a frequency range in which no light is emitted by the hydrogen atom. From the position of the line on the spectrum, the wavelength and the frequency of light can be measured. In first figure, the atomic spectrum of hydrogen series are given: Lyman series, Balmer series, Paschen series in ultraviolet, partly visible and infrared region. In second figure, hydrogen atom spectral transition. In this figure, n values and series are also given. Lines observed in the atomic spectra can be grouped into several groups called spectral series. A group of lines appearing in the ultraviolet region of the spectrum is called Lyman series, while that falling in the visible region is called Balmer series, and so on named their discoveries. Rydberg, after observing the wavelength of a large number of spectral lines of hydrogen spectrum, found that wave number reciprocal of wavelength of any line of the hydrogen spectrum can be represented as a difference of two terms, one of which is constant of the other varies throughout the series. The wave number of series of lines in the spectrum of hydrogen can be represented by Rydberg equation. Mu bar is equal to RH in bracket 1 upon n1 square minus 1 upon n2 square bracket complete centimeter inverse, where mu bar is the wave number of a spectral line, RH is equal to 109,677.58 centimeter inverse is known as Rydberg constant. N1 and N2 are integers having different values for different series. The result of application of the Rydberg formula are summarized in following table, along with the spectral region in which these lines fall. In this table, spectral series and Rydberg integers for the Rydberg equations. In this table, series are given: Lyman, Balmer, Paschen, Brackett and Profound. These series are given, and also N1 and N2 values are also given, and spectral region like UV, visible, infrared regions are also given. Thank you.